Hello everyone. Today our group will present sleep health and lifestyle, machine learning vs deep learning. We will compare models to predict sleep disorders. The slides include 7 parts. The part A is group information and project title. The part B is motivation. The part C is dataset description. The part D is dataset analysis. The part E is algorithm and model overview. The part F is model performance evaluation. The part G is conclusion. The first part is group information and project title. Our group number is 36, include Coulter Zhang, Shu Yijia, and Tian Zhang. Our group title is Sleep Health and Lifestyle. The part B is motivation. Sleep health is important. It's linked with lifestyle, productivity, and disease prevention. Machine learning and deep learning can help us test the prediction ability. Our goal is to find the best model for sleep disorder prediction. The next part will be presented by Coulter Zhang.
So in this section, we introduce the dataset we used in our project. So in this slide, we can see the more details about dataset. We use the sleep health and lifestyle dataset, which contains more than 5,000 samples. And the data includes a variety of features. Some are numerical, such as age, sleep duration, stress level, sleep quality, daily steps, and heart rate. And others are categorical, including gender, BMI, occupation, and the presence of sleep disorder. And the dataset is relatively balanced in terms of gender, age, and health categories, which makes it suitable for training predictive models. And the next section, we will focus on how we analyze the dataset and prepare it for modeling. So in this slide, we can see the presence of dataset analysis. First, the gender distribution is well balanced between male and female, and sleep duration is mostly concentrated between 6 and 9 hours. And stress levels are usually moderate, mostly between 3 and 7. For sleep disorders, most people have none, followed by insomnia and then a smaller group with sleep apnea. And the chart on the right shows the findings. The top bar chart shows the balanced gender distribution. The middle shows that most people sleep around 7 hours, and the bottom shows the stress level are concentrated in the middle range. And in this slide, we describe our feature selection and the subgroup analysis. At first, we retrain key features such as age, sleep duration, stress level, quality of sleep, daily steps, BMI, and blood pressure. And second, redundant features were removed. For example, systolic and diastolic blood pressure are highly correlated, with a correlation of about 0.97. So keeping both could not add new information. So our targeted variable is sleep disorder, which we divided into 3 groups: non, insomnia, and sleep apnea. Looking at the subgroup patterns, for people without sleep disorders, sleep duration is concentrated around 7 to 8 hours. For the insomnia group, sleep duration is generally lower, between 5 and 6 hours. For the sleep apnea groups, which is more widely, with some cases dropping below 6 hours. And we can see the bar chart shows that most people have no sleep disorder, while the box plot highlights differences in sleep duration across the 3 groups. So we come to another slide, shows how we processed the dataset. So for missing values, numerical features were filled with the median, and categorical features were filled with most frequent category, or labeled as unknown if needed. For outliers, we clipped values into reasonable ranges. For example, sleep duration was limited to between 3 and 12 hours, and heart rate between 40 and 180 beats per minute. Finally, we removed duplicate samples to avoid bias. The histogram on the right shows sleep duration distribution after cleaning, and the bar chart shows BMI categories, where most individuals fall into the normal or overweight range. And we can see another slide. And this slide presents our features engineering results. We explore the relationships between different features. High physical activity levels are associated with a slightly longer sleep duration, although the correlation is weak. So stress level has a strong negative correlation with sleep quality. The higher the stress, the lower the quality of sleep. Age is somewhat negatively correlated with sleep duration, meaning older groups tend to sleep fewer hours on average. And the daily steps and the physical activity level are strongly positively correlated, which is expected. The overall stress level and the quality of sleep shows a clear negative correlation, while age and sleep duration show a weaker negative trend. On the right, you can see scatter plots of the physical activity versus sleep duration, stress level versus quality of sleep, and age versus sleep duration, along with a heat map showing correlations among all numeric features. This analysis guides us in understanding which features are most influential for predicting sleep disorders, and it set the foundation for the modeling stage, which my teammate will introduce next.
Now, I explain the models we use to predict sleep problems. I will show you why we pick these models, how we test them, and what result we got. This helps us see which model is best and which features are most important. We use the 4 models in our work. First is decision tree. It is simple and easy to understand. It shows how each feature affects the result. We often use it as a starting model, but it can overfit if the tree is too deep. Second is a random forest. This combines many decision trees. It is more stable, more accurate, and less likely to overfit, but it takes more time to train and is harder to read. Third is NAF-Bayes. This is a very fast model based on the probability. It is easy to use but not very accurate if the features are not independent. Last is multi-layer perceptron. This is a deep learning model. We added it to check if a deep model can do better than the traditional ones on our data. Before training, we cleaned the data carefully. We filled missing values, encoded test features, and scaled numbers for NAF-Bayes and MLP because they are very sensitive to feature size. We slipped the data into the training and testing part with an 8:2 ratio. This gives a fair testing result. We use the same scores for all models: accuracy, precision, recall, F1 score, and the confusion metric, so the results are easy to compare. For tree models, we also check the feature importance to know which features have the most effect. In tree models, blood pressure and BMI were the top features. Random forest also used age and physical activity. This more balanced use of the features makes it more stable than decision tree. This tells us that blood pressure and BMI are the key factor in the sleep disorder prediction. Let's look at the result. Random forest was the best with about 0.93 in our goals. It is stable and reliable. MLP came second, very close to random forest. It shows that deep learning can also work well on this data. Decision tree gives median result but is very good for understanding and teaching. NAF-Bayes was the fastest but the least accurate. It is useful as a quick baseline or the first try. So, by looking at this result, we can see both strengths and weaknesses of each model. In conclusion, random forest is the best model for now. MLP is also good and may do even better if we have more data in the future. Decision tree is still useful because it is easy to explain to others. Newbase is a fast and simple tool for quick checks. So by comparing simple and deep models, we found a strong model and learned which features matter the most. This approach gives us both accuracy and understanding, which is most important when we're using models in real life.
The part G is conclusion. First, the random forest model gave the best result. Its accuracy is 93.2% and F1 score is 0.93. The most important features are blood pressure, BMI, age, and physical activity level. The deep learning model MLP also showed good performance, especially in detecting sleep apnea. For the future, we suggest adding more physiological indicators and using larger datasets. The next is a more detailed conclusion. First, blood pressure and BMI are the most important indicators related to sleep disorders. They strongly affect sleep quality. The second is age and physical activity are also very important. They show that lifestyle factors influence sleep health. The third is in terms of models. Both machine learning models, decision tree, random forest, and deep learning model MLP can identify sleep disorders. Random forest had highest accuracy and F1 score. MLP also did well, capturing complex linear relationships. The fourth is overall combining performance and feature analysis. We can see sleep disorders are highly related to blood pressure, BMI, and lifestyle factors. Both machine learning and deep learning are suitable for prediction and classification in sleep health. Thank you very much. Let's group 36 presentation.